In activity 5.3, we're given the graph of g, and we're asked to plot the graph of a of x, the accumulation function that starts at 1, goes to x of g of t dt. So, on what intervals will we expect a to be an increasing function, and which intervals will we expect a to be a decreasing function? Well, everything still holds true that we know of before. So, it looks like we have zeros at about 3/2 or 1.5, and at 4, and our derivative g goes positive, negative, positive, which means we would expect a to be increasing, decreasing, increasing. And we'll be checking this out shortly. What about concavity? Well, we'd expect it to be concave up any place the derivative is increasing, so 0 to 1, and 3 to 5. Derivative's increasing. Concave down from 1 to 3, and from 5 to 6. Looks like we have a relative max at 3/2 and a min at 4. So we're going to check this all out by finding the values of a of 0 and some of the others. So let's start with a of 0. Now it's kind of interesting on this because we're starting at 1 on the lower limit instead of 0, g of t dt. Now remember, from our property of integrals, that's negative the integral from 0 to 1 of g of t dt. So 0 to 1 is this triangle right here with an area of 1/2. So this is actually negative 1/2 for a of 0 because of this. Negative because we had to swap our limits. Now, a of 1 is going to be the integral from 1 to 1 of g of t dt, and we know without doing any work from our properties of integrals that that has to be 0 if the limits are the same. A of 2 is the integral from 1 to 2 of g of t dt, and now we're going to start seeing the accumulation build up. From 1 to 2, there's as much area above as there is below, so we're going to get a net change of 0. No change in displacement. A of 3 is the integral of from 1 to 3 of g of t dt, which is going to be, and we'll make this split, we won't write it for everyone, 1 to 2 of g of t dt plus 2 to 3 of g of t dt. The reason that's important, we've already done this. That's 0. So this is 0 plus our net change from 2 to 3, which is this area only from 2 to 3, which is going to be 2. So 0 plus 2, or 2. So all we have to do, just like we did in the previous activities, is just look at what's going on with that next accumulation. So we're going to continue this trend. A of 4 is the integral from 1 to 4 of g of t dt, but I already know that it's 2, not 2, excuse me, that should be plus a negative 2. This is below the x-axis, so it should be negative. So we know it's a negative 2 plus what we're accumulating from 3 to 4, which is going to be a negative 3/2. So minus 3/2 gives us a negative 9/2. A of 5, we're going to treat it similarly. We know from 1 to 4, it's negative 9/2. So we just need to do our accumulation here from 4 to 5. Which comes out to be a positive 3/2. So we get negative 6/2 or negative 3. A of 6 is going to be that negative 3 that we already had, plus this extra accumulation of another positive 3/2, since it's above the x-axis. And so we're going to get a negative 3/2. We now have enough information to plot our basically our antiderivative for this particular accumulation function. So we know that at 0 it's at -1/2. At 1 it's at 0, and at 2 it's at 0. Now remember what we said. We said at 3/2 we should have a max. Notice it goes up a little bit between 1 and 1.5, and down between 1.5 and 2. So there's a max somewhere right about there. And we'll see that when we draw our curve. A of 3 drops way down to -2. A of 4 goes all the way down to -9/2, so it's even off our chart here. I'm just going to put a point there. A of 5 is -3, so right here. And finally, A of 6 is -1.5. So there's our plot. Now notice what we said. Concave, it's going to be concave up initially for the increasing rate of change. Then concave down all the way to 3. So we're going to see concave down all the way to 3. Now it's going to be concave up again, and we're going to see that min now at 4. Oops, my point's hiding down here. At 4 there's our min, and now it's concave up to 5, and now it's decreasing again, so we go back to concave down. So there's a rough sketch of our derivative. Now, what if we were to change this to be a of x equals 0 to x of g of t dt, and I'll do this in this other color. Well, right off the bat, a of 0 is going to be from 0 to 0, so a of 0 is 0. Now, a of 1 is going to be the +1/2. And what we're going to see is that everything else follows. So a of 0 will be 0, +1/2. And what's going to end up happening is all our values are going to move up by 1/2. And so we get a vertical translation of our graph up by 1/2. So this is kind of like our initial condition that we saw previously. So as we change that lower limit, we get vertical shifts of this antiderivative, but they will all have the same derivative, in this case, g of x.